Welcome to The Explainer. Today, we're going to unlock the hidden magic that pretty much powers our entire digital world. You ever stop and wonder how your favorite app just knows everything? I mean, how does it connect your profile to your posts, to your friends, to all your preferences? Well, the answer is all about data relationships, and it's this hidden logic, this invisible architecture that we're going to explore right now.
So, before the 1970s, data was kind of trapped. In these old systems, called hierarchical databases, information was locked into these really rigid top-down structures. Think of a family tree. If you wanted to ask a new question, you had to follow a very specific path, from a parent down to a child. What if you wanted to connect a cousin branch directly to an aunt branch? Nope, forget it. It was so inflexible, which made it almost impossible for these systems to adapt, or for us to find new connections in the data.
Then, in 1970, this IBM researcher, Dr. E.F. Codd, he publishes a paper that just changes everything. He asked a really simple but profound question. What if? What if we stopped thinking about data like a rigid tree, and instead, we just organized it into simple tables? Like a bunch of related spreadsheets. And just like that, the relational model was born. This new relational model, it completely rewired how we handled information. Instead of relying on these clunky physical paths, it introduced a super flexible new idea. Just link tables together using common pieces of data. This was a huge leap, right? From physical structure to logical relationships. It gave us a level of flexibility and power that the old systems just couldn't even dream of. Okay, so to make this whole model work, every single row of data needs its own unique fingerprint. We call this a primary key. It's kind of like a serial number for a product or a unique ID for a user. It's a value that is absolutely guaranteed to identify that one specific entry and nothing else. And here's what that looks like in a real database blueprint or a schema. We're looking at the plan for a customer table. See the customer ID row? Now, if you look all the way across to the key column, you'll see PRI. That's the system's way of saying, hey, this is it. This is the primary key. This is the unique identifier for every single customer. And for anyone who's curious about what's going on under the hood, this is the actual code. When a developer builds this customer table, they define fields like customer ID and first name. But the really critical part, it's this line right at the bottom, primary key customer ID. That one simple declaration is the command that tells the database to enforce uniqueness. It makes it literally impossible for two customers to ever have the same ID. So now that every table has its own unique IDs, we can start building bridges between them. And we do this using a foreign key. A foreign key is really simple. It's just a column in one table that holds the value of a primary key from another table. The phone number analogy is perfect, right? It's a reliable pointer that connects you to a unique contact somewhere else. Let's actually see this in action, because this is where it gets cool. Here is our simple customer table. See the customer_ID column? That's our primary key. So Mary Smith is uniquely identified by the number 1, Patricia Johnson by 2, and Linda Williams by 3. It's simple, it's clean, and there are no duplicates. Okay, now let's look at a totally separate payment table. We see a customer ID column here too, but look closely, it's acting differently. The ID 1 shows up twice, and that's okay, because here, customer ID isn't a primary key, it's a foreign key. Each of these numbers is a direct pointer, a reference, back to a specific person in our customer table. And this is the magic moment where it all clicks. The number 3 in the payment table isn't just a number. It's a direct link to Linda Williams. And both of those payments with the number 1 are explicitly tied to Mary Smith. This simple, reliable link between a foreign key and a primary key, that is the relationship in a relational database. This is where all the power comes from. So, we've organized our data, we've built these relationships with keys. You might be thinking, okay, that's a lot of setup. What's the payoff? Well, the payoff comes when we want to ask questions and get information out of the database. This whole structure lets us do something incredibly powerful. We unleash this power with a command called a join. Now, looking at this query, we're basically telling the database, select the customer's name, their address, and their city. Start from the customer table, then join it to the address table on their matching address ID. Then join that result to the city table on the matching city ID.
We are literally telling the database to walk across the bridges we built to put together a complete picture for us. And here's the result. This clean, unified table gives us each customer's full address. But here's the really magical part. This neat table doesn't actually exist anywhere in our database. It was put together in milliseconds, just for us by the database, just following that trail of keys that we created, from customer to address to city. So let's just do a quick recap. We started with disorganized data, and we structured it into tables. Then we assigned a unique primary key to every single row. We then used a foreign key to create a link or a relationship between those tables. And finally, we used a join to follow those links and pull all the data together into one useful result. It's a really simple, elegant process that brings order to all that data chaos.
Once you understand this, you seriously start to see it everywhere. It's the relationship between your social media profile and every single post you've ever made. It's the link between your bank account and every transaction. Primary keys and foreign keys. They are the invisible architecture of our modern world, the silent, powerful organizers of our very, very complex digital lives.